Hello my Pokemon fans, welcome back to another video about Hex Maniac Advance. You're watching advanced tutorial number 5, Font Editing. In this video I will talk about all the different types of fonts in the games. Then we'll be editing the individual characters of the font sheets. Then we're going to be making Hex Maniac Advance recognize the new characters. Then we're going to edit the widths of characters, which I'll explain in more detail later. Then I'll briefly talk about editing emojis and using them in text. For more tutorials on using Hex Maniac Advance, check the description for a link to the tutorial page on Hex Maniac Advance's GitHub. One application of font editing is bypassing character limits for Pokemon, types, and items. As I'm deliberating which move my Latios should use, notice the type names beside the type field. Dragon has 6 letters, while Psychic has 7 letters, and Normal has 6 letters. But if you look inside a vanilla game and go to the table full of type names, each type has 6 characters or fewer, even if it means misspelling the names of some types. Let's try to replicate something like that. First, we need to go over the fonts that we have available. So the fonts we can use are mostly similar to each other, but there are some differences between Ruby, FireRed, and Emerald. You can skip to these timestamps if you're concerned about FireRed or Emerald. In Ruby, Sapphire, and Emerald only, all of the fonts are stored in a table. So I will show you that table, which contains the pointers to all of the Sprite sheets for the glyphs. As you're about to see, there are 9 fonts in Pokemon Ruby and Sapphire, 4 of which are Japanese, 4 of which use the Latin letters, and the last one is Braille font. So what I'm actually going to do is open the Go-To menu, type graphics.txt.font, and it shows you a clearer view of all of the fonts in the game, as well as a palette for the sprite sheets. This is probably a quicker method to find the fonts, and is your only method to find the fonts if you're hacking a different Gen 3 game. I'll do a mini PowerPoint presentation for what the sprite sheets look like. Here are the first 3 Japanese fonts. The fonts Japan 0 and Japan 1 are rendered backwards in Hex Maniac Advance. To my knowledge, the game basically flips them twice, and Hex Maniac Advance only recognizes one of the horizontal flips. Thus, if you wanted to edit those 2 sprite sheets, do not horizontally flip them, otherwise they will look flipped in-game. Then again, if you're editing an English ROM of Ruby, it's unlikely that you'll need to touch the Japanese fonts unless you're allowing trading with Japanese ROMs, or you want to have a character speak something in Japanese. From my other observations, the fonts Japan 0 and Japan 3 are most likely used for overworld text boxes and displaying the text of the items in your bag, while the Japan 1 and Japan 4 fonts are primarily used in battle and in the UI for the Pokemon menu. For a reason I will explain later, edit the fonts that don't look backwards in Hex Maniac Advance first, and if that doesn't work, you can edit the other Japanese fonts. Here are the corresponding Latin fonts. Like previously, Latin 0 and Latin 1 are backwards in HMA. Some decomp contributors hypothesize that Ruby ROMs in languages like German or French use those fonts instead of default and short, like what the English version of Pokemon Ruby uses. Thus, if you are editing an English version of Pokemon Ruby, which is more supported than ROMs in other languages, stick to the default and short fonts. Judging by what's on screen, Latin 0 is basically the European version of the default font, and Latin 1 is the European version of the short font. Switching gears to FireRed and LeafGreen, you're going to see that there appears to be 10 different fonts in the game, but a lot of them are actually duplicates of one another. For instance, the fonts Black, Blue, Other, and Red all have the same character sheets and make up the main font in the game, but they have different use cases. Here I have one instance of each font being used, with a corresponding label to the font name used by HMA. And the short font is used when displaying Pokemon nicknames in the Pokemon menu and the HP boxes. These are the Japanese fonts. that are present in the game's code. Japan 1 looks like a backwards compatibility font for Pokemon Ruby and Sapphire, but there appears to be a couple of symbols that only occur in this font and no other Japanese font. For Japan 2 through Japan 4, those three have the same sprite sheet, but they're used differently depending on what NPC you're talking to. Lastly, Japan 5 would be equivalent to the short font used in English, FireRed and LeafGreen. If all of your gameplay is going to be in English, then you don't really need to edit the Japanese fonts, though it quadruples the workload when you have to edit each character in 4 of the same sprite sheets. In Pokemon Emerald, there are 10 fonts total. Some of them are unused. The bag font is the slim font used when showing items in the bag and move descriptions in the move reminder menu. The black font is the FireRed font. That's actually used in a couple of places, such as the PC and whenever you get a communication error. The other font is Emerald's main font, which is used in NPC dialogue, menu options, and a bunch of other places. The short font is used to squeeze in Pokemon data like levels, HP values, and nicknames into HP boxes. Some of the Japanese fonts are unused, depending on which control characters you're using if you want to make a message in Japanese. The fonts that you can edit are Japan 1, Japan 3, and the first sprite sheet of Japan 2. The thing with Japan 2 is that there are a lot of sprite sheets that are under this name. Only edit the characters in this mega sprite sheet that do not have a white background, which are the ones at the very top, including some emojis. All of the other characters are FireRed and LeafGreen leftovers that are not used whatsoever. Now let's start editing these sprite sheets. These two objectives go hand in hand, so I'll be switching between the two. In the Go-To menu, I'm just going to type text.font to show all the fonts in the game I'm trying to edit real quick. And to start simple, I'm going to edit the main font in Emerald. So here's the sprite sheet. I'm going to use an unused English character to make a character that has the letters I and C. So the psychic type can have 7 letters while using 6 bytes. I'm going to explain something really important, and it's to set a reference point. Since most font sheets have a lot of empty space, you could easily put image data in the wrong spot and have the game render your character incorrectly. Or you could end up using the wrong character byte for the character that you're editing in the sprite sheet. Thus, put your custom characters in spaces that are very close to the vanilla characters. Here, I'll be using this A with a circumflex as a reference point. If you look through these characters in the sprite sheet, you will notice a pattern. Other sprite sheets will have a similar pattern. For a sprite sheet like this, the top left pixel of the character will always be on the top left corner of one of these 8x8 grid blocks. Zooming in a lot will let you see them. There's also one pixel at the bottom that's left behind. This next step is optional, but you might find it helpful. You can basically replicate the white background using the patterns that you found, assuming the character you're editing has a white background, so that it's easier to keep track of that particular character you're editing. When you're making these new characters, you can either free draw it, but if you're using multiple letters, it's best to copy the letters that already exist, so that no one knows that you edited the font. As you can see, I am copying the capital letters I and C in that order. For making new characters like these, you'll have to use trial and error to get the spacing right. I can show you how to make these comparisons later in the tutorial. Earlier, I mentioned setting up a reference point. Well, there's another use case of that reference point. So I'm going to another offset in free space, and I'm going to make a new text string that doesn't need a pointer necessarily. So basically, you type a character that corresponds to the reference point you set earlier, which in my case is the A with the circumflex. Now click on that byte in the Hex Content Viewer and look at the very bottom of your screen. What raw byte is selected? I typed it here for clarity. Anyways, now I have to close HMA entirely. This must be done if you want HMA to recognize changes in certain files. In the folder containing the exe file for Hex Maniac Advance, click on Resources. All I want to edit is the pcsReference.txt file. After scrolling down a little bit, I find my reference point. I'm now going to edit this file by adding another entry for the IC character. You'll have to do this for every character you want to add. State the numerical byte, followed by an equals, followed by the name of the character, which is IC in this case. But the main thing here is a backslash. Pause the video if you want the technical explanation. Feel free to add comments with a hashtag if you feel it is necessary for your character. Let's save changes to this file and reopen Hex Maniac Advance and by extension our ROM. I'm gonna go to the type names table and I will change the second C in Psychic within the Hex content viewer and change it to a \IC. Inside the emulator, you'll see how both of our edits will work together when it comes to displaying the Psychic type. Oh, is the right edge of the screen cutting this thing off? But after looking this color change prompt, it looks like there's something that we haven't accounted for yet. Now I'm trying to do the same change in Ruby. One thing to watch out for is that some font sheets don't have their palette loaded automatically. Thus, one of the things you're going to have to do in the formatting of the sprite sheet is specify the name of the palette after the final number you see. To do this, type a vertical bar, then type the name of the palette that the font sheet uses, which for Ruby and Sapphire, I have it provided here. Now, unlike Pokemon Emerald, the outlines of the characters are light blue, though most of the time they don't appear as such color. Also, as I'm scrolling throughout the sprite sheet, this particular sprite sheet for the default characters doesn't have a lot of empty space, because it's sharing character slots with Japanese characters. I still want to demonstrate editing a character in Ruby though, so we'll edit the font sheet and replace the Japanese character at index 0x69 with the IC character. Let's copy the capital I. So like in Emerald, all characters here start at this top left corner. That's also the top left corner of one of these grid boxes. So similar to Emerald, this is the bounding box of the character. It starts at the top left of one of the 8x8 squares, and the vertical length of the character is 15 pixels. Now I'm at the reference point, and I'm just going to paste over the original Japanese character. What'll be annoying for Ruby is because there's no white background, pasting a new character over an original one will still preserve some of the original character. You're gonna have to fix such errors manually. There isn't much space to put multiple characters, so I needed to squish down the uppercase I. I'm gonna do the same process for the letter C. One other thing of note is that I had to actually replace another Japanese character to fit the C that I was trying to edit. Let's set up a scenario where we can test this. I'll just edit an NPC script and change his dialogue so I can reference the reference point and the character afterwards. Let's show our changes in action. Well, something's wrong. Time to reassess my font change. It turned out that out of 2 white colors in the font palette, I used the wrong one. Let me fix that mistake. After making the necessary changes, the IC glyph loads correctly, although once again we had to compromise on the width. Before moving on, I want to make one final point. If you're making an entirely new character, that character needs to show up in all of the sprite sheets of the game you're trying to edit. Let's make changes to the supersonic move. To show you what I'm talking about, move names are shown with the slim font when selecting a move, and since we didn't edit character number 0x69 in that font sheet, supersonic reads as supersun only. If I show you all the other font sheets and scroll down to the reference point we set earlier, you will see empty slots in the relative positions of where the IC character is supposed to be. You have to fill those in manually every time you make a character. Now we're going to perform the next step to make these characters display properly. Now, a vast majority of fonts in the game have a corresponding widths table. They basically dictate how many pixels wide to actually render the character in-game. But I'm actually going to click the characters table first to determine what number to put for the width. Here's what the width table looks like. You need to find the index of the table that corresponds to the index of the character we edited. One thing you can do is click the edit button, then select show hex converter. Now you need to remember the byte associated with your reference point character, or if you remember the hexadecimal index of your glyph, then you can type that instead. Now you need to go to the index of this table. The base 10 value is supplied on the top right of your screen. This is the cell of the table that you will have to edit after figuring out what the width of your character is. You might find this next bit a little helpful. I'm going to right click and duplicate the tab so I can be in two places at once. I'm now going to open the character sheet in the image editor in one of these tabs. And all you need to do, and this is easier if your character has a white background, is literally count how many pixels wide your character is. I counted 12 pixels wide. Pro tip, each gray square has a side length of 8 pixels. With that information, you now have a heuristic for determining the width of your glyph. Now I'm going to return to the other tab, jump to index 105, which is the index of our IC character, and type the number we just got. You're also going to have to repeat this process for the other width tables that you may need to edit, because as I said earlier, editing one character will have to be done on multiple sprite sheets. As you can see, the psychic type name that we edited earlier is no longer cut off, and you can now see all 7 letters. This does not affect the type icon itself. I should probably update the IC in Supersonic as well. Okay, here's the last objective. This one's all about emojis. So I didn't really touch up on this a lot in my text editing tutorial, so I feel like I should make up for it here. So many of the sprite sheets in FireRed, LeafGreen, and Emerald have symbols way below a region of empty space, and you need 2 bytes to display them. So I'm going to go to one of the font sheets that has emojis at the very end, and I will need to scroll down a lot to see them. As you can see, some of the extra symbols do not have a white background, and a lot of them are empty slots. I chose to edit the musical note. Once again, I have to scroll down in the image editor to get to it. So I take the time to edit the emoji so that there's a second 8th note. So you're seeing me draw another note head and the bar. And to match many of the other vanilla emojis, I fiddled with the emoji's shadow with another color in the palette. Now I'm counting the width of the emoji. As you can see by the 8x8 block that I'm hovering over, I can count the first 8 pixels, and then I counted 5 more pixels for a total of 13. Of course, if I want the emoji to show up in other font sheets, I would make the same changes. You could add a lot of characters on top of this one because there's a lot of space, and you could use that character as a reference point. You need to be careful about where you position your emojis because it's very easy to misalign them on the y-axis and cause graphical glitches in game. In the PCS reference file, all of the emojis can be used by typing \9 and the raw hex code, or the macros you see in brackets on the left side. There is a huge gap between 17 and D0 that you can exploit from our characters. Now I'm at the main font's width table, and I'm going to actually edit the width value for this character that I edited. Now, to determine the index of an emoji character, you take the character's byte after the F9 byte in the PCS file, and you add 0x100 to it. Use the hex converter to convert this sum into a base 10 value. 2 shortcuts I used were using Ctrl+H to show the converter and typing a 1 before the identifier of the emoji. According to the decimal field, the index I need to go to is 489. Change the width of the emoji to the new one you just counted. Now I'm going to test this in-game by editing a script so that it shows the changes to the emoji. I basically click on one of the Kecleons, go to its script address, then I manually go to one of the addresses of its text strings. Here are the two ways you can put emojis in the text tool. First is by typing the corresponding macro, including the brackets. And you can see the \9e9 in the Hex content viewer. You can type that in the text tool as well. Reloading the game in MGBA, you can see the changes to the emojis that we made. One thing I can do better is make the notes taller so it doesn't look all distorted and squishy. And as a reminder, these changes are not reflected in other fonts yet. I would have to go through the other fonts and make the same changes. To close the tutorial, a similar application of manipulating the game's fonts is bypassing the 12-letter limit of move and ability names. As you see Hitmontop's moveset, Thunder Punch looks like it has 13 characters, while High Jump Kick is spelled like it is in Generation 6. Though expanding strings like those has its side effects, it shows you that thinking outside the box is a useful skill a ROM hacker can have in order to solve or work around an obstacle that comes in your way. Thank you all for watching the tutorial. Anytime you find a Hex Maniac Advance bug or crash, don't hesitate to report it. As always, my viewers, continue your pursuits in the field of ROM hacking.